This is a problem here out of 4.3, and it says, first use the Pythagorean Theorem to find the exact length of the missing side of the right angle. Then find the exact values of the 6 trig functions for the angle theta opposite the shortest side. Okay, so let's take a look here. So we have one leg that's 3, another leg that's 6, and we're looking for the hypotenuse, okay? So we're going to do something like this. Okay, here's our right triangle. Let's say this side here is 3 centimeters. Let's say this side here is 6 centimeters. And it's telling me that, let's see, the angle theta is opposite the shortest side. So this is going to be my theta right here, okay? So when we're doing the Pythagorean theorem, you remember a squared plus b squared equals c squared, right? So I can think of that as my a and that as my b. So we're going to say 6 squared plus 3 squared equals c squared. So that's 36 plus 9 equals, get the equals to, okay, c squared. So 36 and 9 should be 45. So 45 equals c squared. So to find c, we're going to take the square root of 45. Now remember, we want to break this down, right? So when I think of 45, I think of 9 and 5. Oops, there we go. Let's make that 5 a little bit better because it looks a little rough. Here we go. 9 and 5, and I know 9 is 3 and 3. So the square root of, since we're talking about square roots, we're getting pairs. So my c here, we have a pair of 3's, will be 3 square root of 5 centimeters, okay? So now, what we're going to do now, let's draw the same picture we had before. Okay, here's my theta, here's my right angle. This was 3, this was 6, and this was 3 square root of 5. So now we're going to do a couple of things. We're going to find the sine of our angle, which is the opposite over the hypotenuse, right? So the opposite would be 3 over 3 square roots of 5. Okay, we can get rid of those 3, so we have 1 over the square root of 5. And now we need to rationalize our denominator. So remember, whatever we have on the bottom in terms of the square root, we're going to write exactly that, right? And then remember, this square root and that square root cancel each other out. So we have the square root of 5 over 5 for our sine, right? Then let's go ahead and do our cosine, right? So our cosine is going to be the adjacent over the hypotenuse. So this is going to be 6 over 3 square roots of 5. We can reduce the 3 and the 6. So now we have 2 over the square root of 5. We're going to rationalize one more time. Square root of 5, square root of 5. So now we have 2 square root of 5. Remember, square roots again will cancel over 5. And now we have the tangent of our angle, which is the opposite over the adjacent. So the opposite is 3 over the adjacent, which is 6. We can reduce that to 1/2, right? Okay, so now let's do this one more time. Draw my triangle again. So we said this was 3, this was 6. There's my theta. This was 3 square root of 5. And now we're going to find the cosecant. So remember, if the sine was the opposite over the hypotenuse, the cosecant is going to be the hypotenuse over the opposite, right? So that would be 3 square root of 5 over 3. That's just the square root of 5, right? And then the secant of our angle, I'm going to come back. So guys, remember, I'm just using those kind of reciprocal identities. So if I know the cosine is the adjacent over the hypotenuse, then my secant is going to be the hypotenuse over the adjacent. It's supposed to be a y there. Okay, so the hypotenuse is again 3 square root of 5 over the adjacent side, which is 6. We can reduce these. So now I have a square root of 5 over 2. And then we have the cotangent of our angle. So again, I'm using my reciprocal identities. So if the tangent is the opposite over the adjacent, the cotangent is the adjacent over the opposite. So this would be 6 over 3, which would then just be 2, okay? So we have 1, 2, 3, 4, 5, 6 trig functions, okay? Y'all got any questions? Let me know. I'm happy to help.